And let's turn on the screen. So where were we yesterday? We talked about these things. We had already talked about. We have talked about this. We talked about method. So where were we yesterday? IO stream. All right. So a little bit of recap. All right. So hi everyone. Can you hear me clearly? Great. So today we are going to continue from where we left yesterday, and probably we left at IO stream yesterday. All right. Let me clean up my workspace. All right, and close this and get back to here. Okay. So yesterday we were talking about this was method overloading we had discussed. Then we were so this is how we read from the files and we write to the files. Okay, and I gave you a demo of how to read from the console. So basically you have to first create input stream reader on top of this stream. This is a stream system.in, and for that matter system.out is also one stream which is provided to you. Okay, so you can have a look. If you press control and then click, then it should tell you that it's a print screen. Okay, it's a stream, basically print stream. Is my voice breaking very much? All right, so let me. Is it better now? Okay, so does it, is it a little better? All right, so other than SEMA, is it okay with everybody now, or still there is a echo, or there are other problems now? Okay, so Vishnu is okay, SEMA is okay. All right, so okay, that's good. So this is how you can read from the input stream, and this is one input stream, and there's a huge hierarchy of various kinds of streams. So there are basically two basic streams. One is called input stream, other is called output stream. You write into output stream and you read from input stream. Okay, so these things are defined in term with respect to you. Okay, that's very important. So whenever each stream which is an input stream can uh, can give you the output, which means you read from it. It's an input to you, or it's an input to others who are reading from this stream. Okay, and then there are subclasses like sequence input stream, string buffer input stream. There are subclasses, there are different kind of input streams which basically extend input stream, and there are various kinds of further uh, output streams, such as file output stream. If you write to file output stream, it will be saving to the disk, and in case you write to the output is byte array output stream, it will be writing to a big byte array. Okay, and there is something called filter output stream, which basically can be used to filter the data, and so on. All right, and there is something called buffer, and in the input stream there are different kind of input streams. So this is the class hierarchy. Okay, this is the class hierarchy of input streams and output streams. Okay, so when you want to read or write, you generally use this stream. The way we have used new input stream reader, and each stream has got, on any stream you can create various kinds of readers. So there is something called stream. Streams are source of data. If it's an input, it's an input stream, then it's a source of data. And if it's an output stream, it's the sink for the data. We give to it. Okay, so here, on for reading the data, there are various ways. Is one is the most basic one is most basic one, that is reading character by character. Okay, other is by creating various kinds of readers. Okay, instead of reading one character at a time, those readers will help us in reading in various ways, such as line at a time, or such as full big byte at a time. So those are the readers which assist you in reading from the streams. All right, so you have got streams and you have got readers. Using readers you can read stream. This example does not have any reader. That is why it is relying basic integer type, and it's reading one number at a time. All right, so if you are writing from files, this will be pretty inefficient because it's reading one character at a time and putting into output, and then at the end of it might be trying to flush or close. Okay, so generally create readers on top of input stream, similar to what we have done here in the previous example. Here we could say new. If you want to read from the file, we could say, in place of system.in, we could say read from the file this way. Now it will start reading from that file. Okay, and also you must note, all right, so and also let me just, now here we could say cin. So this reader would be providing many functions. One of them is okay, so this reader does not provide, but if you want to read buffered input stream reader, buffered reader, okay, then we can say buffered reader and buffered input stream, okay, buffered reader, and that needs to be done on new input. Okay, so new input stream reader, on top of it we say buffered reader equals to buffered reader, and we say cin. Okay, so now instead of doing this way, we could actually say, okay, and we can say create a local variable. Okay, while we can say that br dot read line. So now we can read line here, and okay, let me just clean it up a little bit. So now you can see here that we are reading line by line rather than character by character. Okay, while not line equals to line equals to say q. All right, so this way we will be reading line by line rather than character by character. Okay, so we can also say line equals to quit, and then you'll have to now type quit in order to quit. Otherwise it will be just taking the input and printing whatever you are saying, and the moment you say quit, it will quit. So you can see that here, so what, there are multiple steps we did. No, it doesn't. So as you can see that line equals quit. Whenever we do a buffer reader read line, it eats up the new line character at the end of line. Okay, that's a very good question. So there are multiple steps we did. First, we created input stream reader, and on top of input stream reader, we said buffered reader we want to create, and then we do that. So we can chain the readers with one another. Okay. So that's a very quick demo of how you can read line by line. Similarly, here also you can apply the same principle, and you can create a reader on top of the stream. So there are three steps. First, you create file input streams. Once you create file input stream, you create the reader, input stream reader, and on top of input stream reader, you create the buffered reader. So we are passing input stream readers object here, and we are passing input streams object here. So input stream reader, and then other kind of buffered reader. So basically these all classes are invented in order to provide the flexibility to read and write from any source or sink, and we can chain things together. Okay, so buffered reader, for example, can read from multiple input stream readers, and so on. So that these kind of granularity, when there are streams, and there are, you are extending, I mean, you can even extend your stream so that you are able to you can basically create a buffered input stream on top of buffered writer, where you keep on writing this stuff, and that will become goes to the output stream. So buffered, so these kind of nice utility classes are possible because of the granularity of various kinds of streams and files provided by Java. All right. So, and moreover, the for a beginner to read from sysout, it might look very clumsy. It might look very awkward in the beginning, but after a point of time, you will get used to it, and also you will realize the necessity of these kind of classes. Okay, so as a thumb rule, again, let me reiterate: whenever you want to read from somewhere, you need to create a stream, and after you have created the stream, you create a reader, and then you start reading from using the reader. Or you might like to create a secondary level reader such as buffered reader, which basically keeps a buffer in memory so that you can read the whole line at a time, or other kind of functionalities. All right, so that is the very quick overview of streams. You should definitely relook at it after you have finished the course. My strong recommendation to all of you would be that after we finish this course, you should go through the video again, because this diagram would not make sense to you right now. But once you understand inheritance, you will understand this diagram better. I always had to read programming language book at least more than once. Okay. Mm, all right. So okay, so scanner is something which I had not planned to cover. Scanner, which scanner are we talking about here? So let me see what does. I have actually not used scanner for quite a while. So it says that this basically constructs a new scanner that produces values scanned from a specific file. Bytes from the files are converted into characters using underlying. Okay, okay. So just like buffered reader, there is scanner also. And although you don't interact with the scanners, and I mean, generally, most of your work is done by. Okay. So scanner is similar to what we have reader, but I haven't personally used a scanner yet. Okay. So scanner looks like colleague of buffered reader. All right. Now, other than reading and writing from the file from the streams and to the streams, such as input output streams, there are something called going through the files and directories. Say, for example, you want to list down all the files in a folder, or you want to create a directory. In those cases, you use file class, file file class, and and there and that is your gateway to going through the various kinds of various kinds of file and directory operations. Okay, so for example, you want to list down all the files, so you can use something like file equals to null string paths, file equals to new path, a new file. So this is file is basically a representation of this string, which is slash tmp, and then file essentially is a representation of this string. Okay, so a file, this file basically points to slash tmp, and if I say file.list, it will give me the list in this folder. Okay, you can have a look at this. Okay, you can have a look at this. So in my tmp folder, these are the things that are lying. Okay, and I can show you lstmp. It's the same thing. So basically, this means that file contains these. A file is pointing to slash tmp, and then in case that we want to create some more folder over here, we can say file dot mkdir. It will create all this particular directory. And if you say mkdirs, if the tmp does not exist, it will create the tmp also. Okay, So you can create the directory using this object, this object, file object, and you can list down, and you can also check if it exists or not. Okay, and you can also check whether the file is a directory or so. File is basically an object that represents directory as well as a file. Okay, file basically is represents both. You can, if you say file.exist, it will tell you whether slash tmp dot slash x exists or not, but it won't tell you whether it's a directory or it's a file. For that, you have to do is directory. Okay, and then you can say, okay, similarly you can create another file using this object itself, saying new file. Okay, say you want to create a file child equals to new file, and we can say x. Okay, and on top of it we can say file. So this will basically create a folder called x under the, we can say, make directory, and it will create that. Okay, I'll show you that. So we don't have slash tmp slash x right now, right? And if you run this, it will create that directory. Now you can see that the X has been created. So basically, you can define the parent-child relationship between the file using this way. Okay. So effectively, the file as such is the representation of this string, on top of which you can do various kinds of operations, list, and also, and if you want to say traverse, if you want to say traverse in the whole file structure, here you can do that kind of programming. Okay, if you want to find out, say, file dot get size. Okay, file dot get size, file dot get path total space. Okay, not this, this is wrong. So this function free space is for the partition, if you are talking about partition. Okay, okay, so okay, so length will give you the size of the file. Okay, so see, every directory or file has a length. In case of a directory, it's around four bytes, or it's around 4 bytes each directory. While the file is, I mean, all directories have a small amount of footprint in the memory, and that's the, not memory, on the disk, and that's the length of the file. Although generally the directory size is considered 0. Okay, so and be clear that when we say directory and dot get length, it does not give you the size of all the files in the folder. Okay, for that you have to traverse this folder by yourself and then sum it up, and then you will have to do it by yourself. Okay, so if it's a folder, it's almost like a 0 size. It's being very specific, it's around 4096 bytes in case of Unix file system. All right. So File.length will give you the size or size taken by this directory or the file. Okay, when we say the size of the directory, it does not mean, I'm emphasizing again, size of the directory is a very small amount of disk space being taken by the folder structure. All right, so you can, as you can see here, if you have to traverse, then you can traverse the folder further and keep on going. So you can recursively traverse the folder and then print all the files under the folder. That will be a very good exercise for you. Print all the folders inside folders inside folders using this. Okay. And you can use the recursion over there. For those people who don't know about recursion, recursion means a function calling itself. A function can call itself. Okay. That is something maybe you guys, I would appreciate that part. Now say I'm here. How many of you have known about recursion? So say I say compute factorial, okay, and I say this. So a factorial is if n equals to 1, n equals to 1, return 1, else return factorial of n minus 1 n into this. Okay, so this will recursively call itself. So when I say sysout factorial of 2, and let me put a static here so that I don't have to create. Okay, so when I say factorial of 2, it will basically multiply and give it to me 2. If I say 3, how much will it give it to me? What will be the output now if I say factorial 3? Are you guys with me? So I'm saying this is my factorial. So what will be the number? The output factorial of 3? Anybody else? Chandra? Srinivas? Abhishek? Okay, and Sri Vasant is also there. All right. So basically, using a recursion, we were able to solve a complex problem like this, and that too very quickly. In 3 lines of code, we could compute the factorial by calling itself. But if we do not include these lines and put something of this sort, okay, then it will keep on going indefinitely. And it will say the stack overflow is what you get. Here, see the error? The function has been called so many times that there is a stack overflow error. Okay, and the website called Stack Overflow actually originated from this kind of error. Okay, so this is what we call the recursion. And using recursion over here, you should try out list down paths recursively till the bottom. for the whole file system. If you are on Windows, you provide C colon and it keeps on going inside the folder and keeps on printing all the files. So you should try that out with this. Okay. Or in case you don't want to go for a kind of uh, if you don't want to go for recursion, there are two ways to do it. Recursion, or you could do is breadth breadth first search. Okay, look it up on this. You will understand what I'm talking about. Okay, so now this is how we have covered anyway this part. We can create the folders and under folders and under folders and so on. Okay, so if you want to create a folder with say 200 folder structure, I mean it'll be fun to do things. Okay, so my secret. So this is what we used to do to baffle other people on public computers. We used to say for int I equals 0, I less than 100, I plus plus, and we will just append my file name would be starting with slash tmp, and what we'll do is file name equals file name plus secret. Okay, now this will basically create a sort of 100 label of structure of folders, and then I'll say file equals to new file and file name. Okay, and in this I can say file.mkdirs. So this will create a humongous list of files. Let me show you what will this folder be, and let me just make it a little less, say 30. Okay, so here if you can see this, so I'm saying, so what does it do? It creates a huge file. It creates a huge folder structure, folder inside folder, and and then that folder doesn't have anything in this. Okay, so those people who are using Windows, they will keep on going into the secret folder and they will be baffled by that there's something secret, and they'll keep on going. Okay, let me just change the return statement. So it's this is my function. It basically creates a full big file name slash tmp slash secret and so on. And after that, we try to create file object on top of it, and then we say create all the directories represented by this file path. Okay, so you can see this. Now inside this, okay, inside this, you can see that there's so many folders inside it now, right? So those who are curious, they will keep on going into this folder just to find something, and uh, and then they'll get, you know. Okay, okay. So yeah, sounds good to you. And so this way you can do a lot of complex operations over your file system, over your reading writing files. You can do all kinds of things. Also, now when it comes to managing the code, or when it comes to a larger section of code, when you're building a product or anything beyond few files, if you're going, you would require a solid way of handling the errors. A function a function returns only a value, right? Sometimes you want a function to give you the error code as well, and we want function to break and does not go anywhere any further the moment it encounters an error. Okay, for example, in our previous example here, if this tmp does not exist, if slash tmp does not exist, we want the program to break immediately and tell us the reason why the program has broken. So this secret folder which we're trying to create here, okay, the okay, just a second then. Now can you hear? No. All right, can you hear now? All right. Now it's not breaking, right? All right. So here, imagine that while we were trying to do some other things here, we realize that this folder does not exist or some other error happens. We do not want program to proceed any further, whether it's inside loop, outside loop, wherever it is, it should just exit from that function, right? And a function has no way of telling the error other than returning a value. So either we engineer all our functions such that they return an object, and that object should have two things. One is the actual return value, and second is the error number, if any. Okay, and a flag that the error actually occurred. So that will make our life really, really complex. So this pattern of error, or this tendency of error handling, is global. In every product, in everybody needed this. That is why Java and other languages came up with the organized structure of handling error. Okay, otherwise people were handling errors by doing go to the error label this, go to error label this, or by creating big object. Say in C, we used to return an error number. Okay, we used to return an error number. So say for example, like index of function, in case of string, we say what is the index of a. Okay, if it is found, then it returns a positive number. If it is not found, then returns a negative number. So that is one way of handling the errors. That is one way of handling the errors. So to make that proper, Java has given a good support for exception handling. All right. So one is you define a function to throw an error, and second is you create the blocks to handle the error. So this function deposit, if you look at this, we are saying this is my class name. It has a function called deposit, and it takes this argument as amount, and it throws this exception. It throws that exception. Okay. And inside this function, there is some implementation, and the moment it encounters a problem, it raises an exception using this way. It says throw new remote exception. All right. And while handling an exception, what you do is while you're calling this method anywhere, say here, when you're calling some method, you are putting a catch block around it. All right. So this is like basic form of things you created. So this is the basic one. You created an array and you are trying to access the element on the index which does not exist. So it will throw an array. Okay. There could have been one way that it returns a number, say minus 10,000, which means that array index is invalid. Or it throws an error. It throws an exception. So in case of Java, this kind of behavior throws an exception saying array index of bound exception. And if you want to handle it, you handle it or you throw it further. Here, here you can handle it by yourself. If you can handle it, handle it. Meaning if you want to take a corrective action when the index goes beyond something, does it mean anything to you? Can you handle it? Can you do an alternative behavior? Or you want to just tell the caller of your function that, hey, this is beyond my ability to handle. You take care of it. So what you do is you say throw E. So now you're further, whosoever is calling your class, we're going to get this error whenever they are trying to do something. Okay. Or you don't throw it, you eat it. Eat it as in consume it, meaning you do something about an element not being found. Okay. So a general tendency is, as a thumb rule in a large program project, what you do is you try to capture the errors as much as you can and then see if you can do something about the error you have got. If you can't do something about it, just throw it further and then let it go. Okay. And the general syntax is try to do the things here, and also note that the moment the error occurs, nothing had there been a statement here, had there been a statement say here saying 1, okay, it will basically this will never be executed. This will never be executed because the moment you encounter exception error, it just jumps to the catch block. Okay. If the catch block is not there, then it goes to the caller, whosoever is calling your program. Okay. So everything breaks at the point the error occurs. Furthermore, if you are expecting more errors, more kind of exceptions, you handle those exception, file not found exception, and invalid input error or whatever you want to do. You be specific while saying catch blocks. Okay. Or if you want to handle all exceptions, then you generally say except this. You generally say exception E. This will catch all kinds of errors, exceptions. And in case whether whether a problem occurs or not, you want to take some some action, such as close the file which you opened, release the resources. Okay, that you write in the block called finally. This finally block is executed no matter what. Okay. So the catch block gets executed only if an error occurs, while the elements below the point where exception has occurred will not get executed if error occurs. So, and even this will get executed if you caught all the exception. But in case an error occurred here and you are not catching anything, this will never get executed. Okay. All right. So when you are generally creating functions, you tend to create you tend to throw exceptions in case of problems. Okay, such as illegal argument exception, such as such as account overflow and all that. So let's take a look at this bigger picture. So let's say you're creating a bank account kind of you're creating a bank account. All right. So this is a checking account. You have a constructor here. These are the private variables saying balance and number. These are private variables. And this is the constructor. When somebody is creating an instance of this, then they will use this way. To and when this function is called deposit, the balance increases. While somebody tries to withdraw, then it reduces the amount from the balance. Okay. somebody and then in case the balance is negative, if the amount left is less than the amount you are trying to deduct is less than the total balance, that means that there are insufficient funds in your account. Okay. So you throw your own exception, but for before that you will have to create this exception in this format. You have to write public class, your exception name, extends exception, and whatever arguments you want, you can create. So this insufficient funds exception is just another class. And here, when you are throwing it, you are basically throwing an object which will be available to the caller of your program. Okay. So here is your, you know, bigger picture. So here is your the way you are calling. You created a checking account, and then you created doing something here. You deposited 500 into it. You are withdrawing 100. Then ag- and then again you're trying to withdraw 600. This time it will give an error, right? This time it will give an error. Oh, this is not running. So we say run as this. Why doesn't it run? Public static void main. Oh, M is capital. So you can see that insufficient funds. One thing that I'm confused, sometimes we use this dot amount and sometimes we just use. So, okay. So to be very, very clear that we are talking about a variable outside. So let me show you. That's a very good point. Thank you for coming up. So what does it mean is sometimes we are using this and sometimes we are just saying uh, without this. For example, so the reason is here this name and this name are same. Okay, had you used some this way and like this, then it could have been easier. Okay, so when we say this dot number, we are specifically okay. Now is it still breaking? We'll have to do something about it. Yesterday there was no problem, right? All right. So it's only sometimes it starts breaking. So here now you can have a look. This time we did not need to put this dot something. Okay. Reason being, here if you say this dot number, then you specifically are saying this means this current object which is going to be. Okay, this is a special keyword which represent the current object we are talking about, and this current object has got these two variables. If we create a local variable, say int x, okay, int x, then and then we try to say this, then it is invalid. Okay, so when we don't want to create any kind of confusion, when we don't want to create any kind of a confusion, then we specifically say this. So if you be with me for a minute, then I'll try to reset the router and then see what happens. And I'm resetting the router. All right, so now can you hear me now? I have just resetted my internet connection. Am I audible? All right, so let's just hope that it works. Okay, so we were talking about when we use this, and this is specifically when you want to be very clear about which one are you talking. Okay, and specifically when you have a local variable with the same name, you can always have a local variable with the same name. Okay, inside a block. So here you have local variable int number, which is same as that one. Okay, similarly you can have int balance here. Okay, can see that. So we can say this dot balance equals to balance, not this one, balance into 10. Okay, so to avoid a complete confusion about a local variable or the instance variable, we use this. All right, I hope this is clear now. So okay, if we keep a local variable different, say num, we can use, of course, see, we are able to use the same code like this, and we can say num, and we can say num, and then it works perfectly fine the way we are expecting it to. All right, so now this particular program is clear to you, or should I explain again stepwise? What does it do? This will be very important thing. So basically first let's have a look at what we are doing with it. It's basically a demo of what happens when your account is overdrafted or amount is underflows, meaning you tries to withdraw more amount from your account. So you created an account instance saying my new account is this. We added some value to it. We deposited 500 rupees into it, and then we try to withdraw from it. Okay, we try to withdraw 100 rupees first, then we are trying to withdraw 600 from it, and that's the time we want to raise an error. Okay, how does this class looks inside? And also when you're using Eclipse, you can press Control and click on a variable to get into its definition. So here what we are doing is it's my class checking account. It has got two variables, balance and this. It has got this constructor which basically assigns the value to a member from the argument. All right, we assign the value from the argument, and we say deposit in order to deposit the amount. When you deposit, this balance increases by this amount, and when you withdraw, in case the amount is less than what you're withdrawing, then it raises this exception. Okay, and this exception is your own class called insufficient exception, and that extends exception. We'll talk about what does it mean by extends exception. So, okay, basically this defines that you're trying to create an exception class, and exception class is just like any other class. All right, so this way you can create a kind of your own exception class. Good for you? I mean, is everybody okay with this example? All right. This is important because this is the classic example of any Java code you will encounter. Now, I'm starting something very important now. It's called inheritance. Though we have been using inheritance since the time we started this session, and we have encountered multiple cases. Say, for example, insufficient balance extends exception. So, this was inheritance. Inheritance means creating another object, creating another class from an existing class, extending a class. Okay, so when you have two different objects and there is a very big overlap in the behavior and you want to extract out that behavior separately, so you create a class, and then you create these two separate separate you create a separate class from which these two will start extending. Okay, so by the way of inheritance, one class or one object inherits the function, the member variables from the parent. Okay, so here let's say there is an animal class which has one member called weight, and it has a constructor, meaning when you are creating an animal class you will pass weight, and the weight will be assigned to the local variable, and after that there is a function in this animal class. So when you call this move on an object of animal, then it basically will print I can move. And if you call a function eat on this object, it will call yum yum, and whatever stuff you give as an argument, it'll say yum yum stuff. All right, now there is a dog which is basically an animal, so every characteristics of the animal should be there in dog. Okay, so we make a dog class and we make it extend from animal, If we had one more class called cat, we'll also say extend it from the animal. All right. Here you can see that there is something called super also. So when we are creating an instance of dog, we can optionally use the parent classes constructor instead of copying that code from the parent and then trying to do that. So we say that create an animal using this argument weight and assign the name to the local variable my name. Okay. All right. So this way you can create a class which extends from another one. And here this class is also introducing one more function called bark. So effectively, when you create an object of dog, it will have three functions. One is move, other is eat, and third one is bark. Okay. So when you run it, the first line it will give is I can move. Second is yum yum bread, and third is I am Tommy and Bhabo Sandeep. So basically, basically we created a class from another one. If we did not have inheritance in place, we'll have to have these functions inside the dog itself. And if we had another animal called cat, we would be having the same two functions in the cat also. So effectively, there would have been a lot of duplicity in the code. It would be very difficult to create a big program without using inheritance. Okay, it would be very difficult. Okay, so and also let's talk about a bit of about nomenclature. Here, dog is a subclass of animal. Animal is a superclass of dog. Also, the subclass called dog cannot access weight. If it tries to print here if it tries to print weight, then it'll give you an error. Oh, sorry, you won't get a baba. You are right. You'll get instead this one is a polite one. So instead you will get I'm Tommy comma Sandeep. Okay, this is what you will get. You're right. Thank you, Chandra. Okay, and that too little bit would be like this. We have two functions, dog name, weight, and public dog this. Which one is public? Why one is public and other is not? Okay, so this has to be public actually. Okay, by default, it's up to you how you define your constructor. Right now, I have defined it as internal, meaning it is only available in the whole package. The third party will not be able to use it. Okay, although it's by mistake that I did not put a public here. And I did not put public here also. So public means if there is a third party library, so you say you created this whole package of yours and created a jar out of it. There is another third party library from a different package. They try to use your class. Then for them, this will not be available. Also, if you mark it private, if you mark a constructor private, okay, say here also, if you have let's say let's say there is a checking account, and in this you create a private constructor. Okay, you say this is private, and this is also private, in the sense that this is also private. And now nobody will be able to create an instance of your class. nobody will be able to create the instance of your class. Okay, now you'll see the errors. Here it says, here it says the constructor is not visible. Okay, so there are cases when you do not want people to create the instances of your classes. Okay, in those cases you make your uh, class private. So by default the members in a any class anywhere, if you don't specify, if you don't specify the modifier, everything is package. Package means it is visible within the package. Okay, so shouldn't we be able to access weight from dog? Okay, let me go back to the demo. So here you will not be able to access the weight from the dog here. Okay, because it is private. In case you want weight to be accessible, you mark it protected. Okay, so when you mark something protected, you say that make this variable visible to all the people who are extending this class but not to anybody else. So a protected variable will be accessible to the class itself as well as all the subclasses of it. Okay, also if you do not want people to be creating the instances of your class, you can also say final here, and then people will not be able to. Yeah. So by default, since, sorry. So yeah, by default, if you did not put here, it will be actually visible here. I'll show you that part. Here, where is my animal demo? So here, if you don't put it here, that's correct. So this is my main function, and I can actually access, you know, my name here like this. Okay. So similarly, we can also access Tommy dot weight. Okay, and that'll be okay. So when we don't define anything, it's sort of like a public only, meaning it's package, it's visible to the whole package. And so you can do inheritance in another way also using implements keyword. We'll talk about implements after 3 slides. And that's pretty much about inheritance. So any questions with respect to inheritance? So when we inherit something, you inherit all the functions and you inherit all the behavior as well as the member variables. Okay, what you don't inherit is the private variables. You can't access them, although the behavior would be there. Any questions on inheritance? Everybody okay? Good. It's okay. We can extend it to one more class, but let's be be clear about what we are doing with it. Okay. So Abhishek, Chandra, Srinivas, Srivasant, is everyone okay with inheritance? How do we track all the references of a public class? That is good. That's a very good question. Chandra's question is, how do we track all the references of a public class? Good. So what you do is, say we have got dog here, right? Now every time people are going to create the instance of the dog, okay, what you're going to do is you are, how should I say, okay. So let's say we create an static variable, okay. First, I need to understand why exactly you are trying to track it. Okay. There are two ways. One is have something called creator. Let's say dog factory. We call it dog factory. Dog factory's duty is whenever you ask dog factory to give you a dog, it will create a dog and give it to you. And dog factory will make a note of it and keep it with it. Okay. The other way is to have a static variable inside dog which will try to track it. Okay. We have an array, static array inside dog, and as soon as we create the object of dog, we add that to the array. Okay. That is another way. Okay. So let's say we say static int dog counter is 0. Initially that is 0, and when we say main, here we keep on creating new dog, and so on. We do it a couple of times, and then we say system dot out and say dog dot dog counter. Let's say how many are those, although where is that? Here there is dog counter, and every time you create an instance of the dog, you just increase this variable. Okay. Now what exactly is the problem with our demo? It says that this is private. Okay. Now, so you can see the 4 is there. So we created dog 1, dog 2, and dog 3. Sorry, these are 3 dogs, and 1 is here. New dog is 4 times. Okay. Is there a way to know all the subclasses of a class? Not really. Not really. Okay. Say, for example, say, we can extend any class, right? We can extend system.in right now and then say that we are doing that. But we, that won't be able to track it. Instance label as in, so we are creating separate instances of the dog class. Yeah, Chandra, I'm feeling that you have got a very good question. Yeah. So generally what you do is, let's take a case of a very simple case. If multiple programs are using this class, then we will not have the true count. Yeah, you won't have the true count. Uh, I mean, in the sense that you can only count number of objects, but you cannot count who all are using it. unless until you put a counter on each function which people are trying to use. So what do you mean by basically in an organization, if we have to change a master class, how do I identify all the impacted master programs? Basically in organization, if I have to change a master class, okay, and how do I identify all the impacted programs so I can alert the corresponding team? That's a very difficult question. It's a very difficult thing to do. So exactly same as what Seema was also saying, that can we track all the people who are extending a master class? Okay, so if there are hundreds of people who are extending this master class, they will be impacted. Similarly, if there are people who are using your master class in their program, then you won't be able to figure that out. Okay. Here, in the running duration, in the running time, we are able to count how many times we are creating an object of a particular class. This is runtime. Okay. So what exactly are we doing? We are trying to count how many instance we created. Okay. If somebody had created this animal class, somebody else, okay, they would have no clue about how many instances have we created of animal. Okay. They will have no clue. This is similar to third-party jars we are using, and then that jar went on for some changes. Those changes are related to the compilation errors or some other things. Okay, if there are no, I mean, how should I describe? Mm, Okay, so basically your problems are a little different. Here we are talking about runtime when we have an object and we are trying to count the objects in the memory. Your problem is that there is a master class, there is a library, there are hundreds of people who are using it. Now, how do I find out who all are using my class, not the objects, right? So such kind of problems can only be solved by checking. If I'm in your place, what all will I do? What all will I do is first I'll find out where all my jar is shipped. Okay. I my jar, whosoever has taken this jar would be using it. Okay. And and then there will be multiple programs, right? These are multiple programs. If it's a single project, you can actually say here animal is there, animal is being used by main class, right? Main class is referring it. So if you have to find out in this project, you can simply here itself you can use the search function. You say references in the workspace. Now the classes, you know that this is the person who is using the class. Okay, so that's one way. I'm trying to understand what exactly is the use case. Is this what you meant, Chandra? All right. So that is something to do with the static analysis of the code, not the runtime one. Okay. Here we are talking about runtime. Okay. Let me talk about another use case. Say in your program there is a configuration. Okay, this configuration you want in the whole memory. When people are using your class, in a memory there should be only a single class. All right, there should be a single dog that can be created. Okay, so such classes are called singleton classes. All right, such classes are called singleton classes, and in those classes what we do is we basically say this is my private object. Now I create a public static function which returns dog. Okay, which returns dog, and it says that the dog with a name. Okay, and it says private static dog, and here by default we can set an object to null so that we can check if it has any value or not. It's like 0 in terms of objects. If dog equals to null, then dog equals to new dog with this name, otherwise return existing dog, right? So look at this code carefully. This is a pattern. This is a pattern which is used for creating a class which has only a single object all across. What we did was we said that our constructor is private. You cannot create an object from outside. But this constructor is locally available. Okay. This constructor is locally available, which means this class can create the instance of the dog. And whenever outsider comes in, they always ask this function to get the instance. Instead of calling new dog, they will use this method called get me an instance of this. And then, yes, so you can only create anybody who you see, you got the error everywhere. Okay, you got the error everywhere, which means now what you have to do is you have to say dog dot get this. Okay, and so on. Now it'll be a single dog like this. No matter what you do, you are actually you are not creating a newer dog. Okay, so the total instance count are 1. Okay, so this is a little tricky. I have just tried to compress everything into one. Here what we did was we made the constructor private, which means anybody else cannot create an instance of this particular object. Okay, and private variable is only available inside the class, even if it's a static function. Okay, so we created one local variable. Okay, for the first time when user tries to access it, dog will be null, and then in case dog is null we create it, otherwise we never create it. For the next time when in the next call dog will not be null, and hence this new dog will not happen and old one will be returned, right? So this kind of a behavior, when we want to control, we want to say that only one instance need to be created, comes under something called a singleton pattern. If you are planning to go ahead with a little bit advanced, the next step should be that you learn about patterns. These are design patterns. So this is a singleton one, the most basic one. Then there is something called factory pattern. In case you want to have only 5 instances of a class, then you can do that. Okay. So is this singleton pattern clear to you? Although this thing doesn't come under Java basics, but sometimes it is needed to know. Chandra, did I make a point? So say you have a configuration class in your program. So this configuration class is common across the whole system. You do not want anywhere else this configuration object to be created. Okay. Yes. Okay. So generally whenever you are creating a configuration class, or say a class which represents the global variable for the whole system, you generally prefer to create a singleton class. All right. Otherwise, say let's imagine that when the configuration of your product is being stored in a file system or in database, and you want your a- a- and this configuration object loads itself from the database. Now, every time people try to create a configuration object, it will try to load from the database. Also, if one person changed it, it won't reflect for other people, right? In those cases, because they'll be creating their own object, playing around with it, and it won't have impact elsewhere. Therefore, sometimes you want only a single instance of something to be used globally across the whole product. Okay. Similarly, say you have an event bus. Event bus's role is people raise event and people handle the events. Okay. In those cases, these kind of pattern come very handy. For example, other would be when we say system.out. Okay. System.out is global for all. No matter who calls this, they are all referring to the same object. Therefore, system.out is essentially a static object. Good? Alright, so I mean, we are basically jumping ahead, but that's good. That's good because if you visit these videos again, you will everything will make more sense to you. Okay? Okay. All right, actually for the database thing, I would need to do couple of things. So to do a database access, basically there are few things you do. First, I will have to do local installation of database first of all. Second, I'll have to do find the driver, Java driver or JDBC driver. Add that jar. Okay, add the jar to project, and then I'll have to inside my code I will have to do this class dot for name and then the driver name. Here would go the driver name. Okay, and this will register everything, and after that you can start using driver JDBC driver and so on. Okay, actually I don't have something ready, that's why I'm just giving you the steps. You can use that. Okay. It should not be any difficult. The problem occurs when you don't know how to check, how to debug your problem. Generally, the problems occur here when people try to create I mean, first you should check whether are you able to connect to the particular. server at a port. So you use nc netcat or telnet. Say you have started MySQL server, so you will have check your database 3306. They'll give you an idea that database is running. If you are able to connect to this, then it should be fine. You should be able to connect here as well. Okay, I could have shown you, but right now I don't have that. Okay, all right. Now the next step, so this was inheritance. There are few more notes I want to tell you. Every class, this animal class, even this animal class, implicitly extending a class with the name capital, with the name called object. Okay, every class extends this implicitly. All right. So dog extends animal and animal extends object. Okay, so this way all the objects have common functions. Dog the way dog got move and eat from animal, it inherited these two functions. Similarly, animal has inherited few functions from the parent. One is hash code, other is toString, and other is compare to, and then is equals. Okay, right? So what does it mean? The hash code basically helps the object when they are being put into an hash table. Okay, the whole object is converted into this number for the purpose of making it a key. Okay, and toString converts the object into a string. So if you want the dog to be converted to a string, okay, then you would implement a function called toString. If you don't implement it, you will get the garbage when you try to print. I'll show you this. So let's say we go to this function, not this. This is a different class. All right, now let's have this in place. Okay, here if I try to run it, you see it printed h here. So if we put whatever name we are putting, when we run it, system.out is giving us that name. Okay, so by default whenever you try to append to any kind of string operation along with an object, it get converted into a string using the toString functions implicitly. So by default, D got converted into Harry when we try to append exclamations to it. Okay, so this essentially is equivalent to saying D dot string append these three exclamations. Or the system.println also tried to convert it into a string, and there we go. Okay, so if we did not implement toString over here, what happens? Let's see. Okay, now we get the memory address of this object, that is the default implementation. So we overridden few functions from the parent class. Okay, the parent class has a function called toString, and that toString gives this. Okay, so we overridden this, and when we run it, it's our function that is getting called. Okay, so three things here. First, we can override the function from parent. All right, and second is these implicit functions need to be implemented in order to test, in order to uh, you know do various kinds of things. Similarly, there is a function called equals which you can implement for your own class the way you want it, so that when when you are using this object for in the hash table or array list, the lookup becomes simpler and possible. Okay, because when you are putting these objects into an array list, or you're trying to do binary search, for example, the equals function will be used. Okay, because it is assumed that every object has equals function, and all these algorithms, they use the equals function to do various things on your object. Okay, the way I demonstrated yesterday, we did a binary search yesterday on an array. If we had an array of dogs and we are searching for Harry, okay, it would be easier if we use that one. Okay, now, so we need to implement things like when we are creating a new class, it is generally suggested that you implement hash code as well. Hash code is the number representation of your object. Okay, specifically for the cases when your object is being stored into a hash table. And to string converts it into a string. You can implement it. Similarly, there is something called compare to. Compare to is used when you are ordering the elements. If you call array.sort on a list of dogs, if compare to basically compares one dog with another. Okay, it's a part of the behavior of the dog class itself, which tells you whether one dog is bigger than the other. How does one dog compare to another one? So that when you are sorting a list of dogs, you this function will be used efficiently. Okay, so if you are looking for things, then equals will be used if you are looking for say binaries. In case of binary search, equals will be used, and in case of array.sort, this compare to will be used. Okay, so imagine that you have an array of dogs which you have added, and you are trying to sort them using array.sort. Now this array.sort has no clue about dog. The only thing it knows is that every object has something called compare to. If your dog has implemented that function properly, then it will be able to sort it using again and again the compare to function on two objects. Make sense to you? Okay. Now imagine that let me just put the height also. Okay. Height, and let me put height here, and then we say height h equals height, and here like this. Now we create an array of dogs, new dog, and we say new dog, and first is say first, and is height is 1, and then there is another dog whose height is second, let's just say 2, and his height is 1, and then there is a third dog whose height is say 4. Right, now we have got this list of dogs, and say we say system.out sysout, and we say array dot toString, array dot toString, and then say dogs. So arrays class, as we discussed yesterday, has this facility to convert it into a list of strings. Now you can see that. So toString basically converted each dog into the name. Okay, because we have implemented toStrings. Now if we try to sort it, say arrays dot sort. Now arrays dot sort, and we say dogs, and then we print it. What will happen to this? Okay, here it says that dog cannot be casted to comparable. Okay, and therefore, okay, arrays dot sort, and then dogs. Okay, and each okay, then you'll have to say implements comparable, implements comparable. Okay, and then you have to implement compare to. Okay, you'll have to say dog this, return this dot height h less than o dot h, or we just do subtraction. Okay, so this way you can implement a comparison. Now after you do this, okay, so so after you do this, it will be able to start comparing over here. Okay, basically this compare to tells the object. I'm just wondering why isn't public and so if I don't implement comparable, what will happen? Yeah, so this guy want it to be comparable. Never mind. So the point I was trying to prove and I was trying to explain to you is these are the basic features of object. There are few more such as finalize, wait, and those are for threads and for multi-threaded programming. Okay, now on the next step we have, this is fine. Now so as a object oriented programming, we have something called is a relation and has a relation. So whenever something extends something, that is a relation. For example, dog is an animal. Okay, while dog has weight. So any member, if a class has got member, the relationship between a class and its members is a has a relation. While while the extents or implements, we'll talk about implements very quickly, is so implements is a relation. Okay, implements, when a class implements b, the relation between a and b is a relation. Okay, for example, car has steering, car has gears, and car is a vehicle. All right, so okay, the other things which we have been anyway doing is, so when we talk about object-oriented programming on the theory level, object-oriented programming means your programming language should support inheritance, encapsulation. Encapsulation as in it should be supporting hiding of the internals of a class. Okay, so the users of this vehicle class would not know about how this vehicle is talking to the gears, talking to the gears or talking through the wheels. That is the internal matter of the vehicle. So these kind of functionality is provided by Java, which means Java gives you encapsulation abilities. Okay, by putting private kind of variable, those all complications are hidden from the user, and when user uses this vehicle class, all they have to do is vehicle dot ignite, I mean start vehicle dot start and vehicle dot move and vehicle dot accelerate, vehicle dot change gear, and so on. They don't have to deal with individual wheels. Okay, they don't have to handle individual wheels at all. So that is encapsulation. Now polymorphism is something that I would like to explain. Now, if we had an animal, we extended it, we created dog out of it, and then dog is still an animal, right? So ideally, we should be able to assign an instance of dog to an instance of animal, right? So if we had cat extends animal, that animal cat equals to new cat will should be possible. So you can see here on the left hand side, instead of putting dog here, we have animal. Okay. And then we can call these functions. Okay. The other way round is not possible. Saying dog D equals to new animal is invalid. You cannot cast animal into dog while you can cast a dog into animal. Why? Because a dog can do everything what animal can do, but vice versa is not true. Okay. So if there is an employee and there is a manager and then there is a CEO, CEO extends employee and manager also extends employee. So manager can do the work of an employee, but employee cannot do everything which manager is supposed to do. Okay, why? Or other way you can remember it is there will be more functions in the dog as compared to the functions provided by provided by animal. Therefore, even if we casted an animal into dog, where will we bring those functionalities in that in that object? Sounds good. So this behavior is called polymorphism. Your object, this pet, which is an instance of animal, internally it is still a dog, okay? And we are just referring to this dog as animal at this moment of time, okay? So if we had a cat and a dog and a hen, they all are extending, all three are extending animal. They all are extending animal. Okay. So we could create an array animal called pets equals, we could do here new animal. We could create an array containing dog, cat, and hen, and then we could iterate over these animals and 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 make them move. Okay, so that is the biggest benefit of the inheritance. All right, so instead of saying dog.move, cat.move, hand.move, if there are 50 objects, you could iterate over them using a single loop. Okay, now Seema's question is, can we do pet.bark here when we say animal pet equals to new dog? No, here you cannot do that. If you do that, it will give an error. It'll say that bark does not exist in the class called animal. In case you are very sure that your pet is a dog, if your pet is a dog, you can forcefully cast it into a dog this way. Now this is a dog. By putting brackets and putting a class name, we are forcing Tommy, we are forcing our pet to become the dog here, here, and then making him bark. This casts the animal into dog, and then we are making him bark. All right. So this is called polymorphism. Okay. Also, on the similar line, we could say object O, and we could say pets 0. So an animal could be casted into object. Why? Because animal extends object. So dog is also subclass of an object, and hence dog can be casted into an object. And we can say o dot equals o dot to string, and still it will give the correct results. All right. Yes, we can use only the animals method in this case. All right. This is called polymorphism. Now again, we can override the default behavior the way we overridden toString in that class. Similarly, we are going to implement a new way of eating. While this animal says yum yum, the our dog is little finicky, it says yikes. Whatever you give it, it say yikes. While the animal is generally happy that it got food. Okay. Now, so when we create a dog here and we say pet.move, what will you get? I can move, right? And when you say pet.eat bread, then had it been the default animal, it would say yum yum. But it's a dog. It's a dog which we are referring as animal here. Okay. That is why we will get yikes. Okay. If we create a second pet which is a default animal and then we call this, then will get yum yum. Okay. So this is very crucial to understand. So here we are saying animal pet equals to new dog, and we are saying pet dot move. So this method is being called, while when we say pet dot eat, this method is being called. Okay. And why so? The moment our dog extended animal, it overridden the default behavior. And here it's actually the dog which we are referring as animal. Therefore, eat bread gives yikes. Make sense? All right. Now, so these were like complete classes. We could create the instance of these classes. Now, there are few classes which we do not know, which are incomplete in their behavior. Okay, or these are theoretical animals which do not exist at all. Okay, so generally when you are building a bigger system, there will be instances when you know that there are two subclasses which have a common behavior. You have taken that common behavior and created a superclass to both of them, but this superclass independently does not make any sense. Okay, independently does not make any sense. You do not want people to be creating objects of this class. Okay, in those cases you generally mark this class as abstract. Okay, so an abstract class is a class which should not be instantiated. You do not want people to be creating instances of abstract class because, but you want people to extend the abstract class. Okay, because by definition it might be it does not make much sense to have an abstract class, have an instance of an abstract class. Okay, the other part is that sometimes when you're creating a class, you do not know how exactly the internals of a function would work, but you want them to be part of the class definition. Okay, so an abstract class can have functions which are abstract. If you are coming from C++ background, these are virtual functions, meaning these functions do not have any implementation, they are just a placeholder. So any class that is going to extend an abstract class will have to implement these abstract function. Otherwise that subclass will also be marked as abstract. Either you mark your subclass as abstract or you implement all the abstract methods. A concrete class, the way we had been using our animal and dog and all of these were concrete class. You could instantiate them. A concrete class cannot have an abstract function. Okay? An abstract function is one which does not have a body, it only has the declaration. Okay? So here, this is the way we have. Okay, so we have something called a graphics object. It has got these two methods which do something internally. Okay, and these two are same, right? I think the two are same. So even if you don't have these two functions, still it is abstract class. You cannot create an instance. If you try to create instance, you will get a compile time error like this. Okay, and these classes don't have to have constructors. So this is called abstraction. Oops provides abstract class and we call it abstraction. Part of abstraction is part of your oops programming, object oriented programming. All right, the way you had an abstract class where you have functions which were placeholders which were forcing all the subclasses to implement those functions. Okay, similarly if you want a lot of I mean all the functions to be abstract, you might like to go for something called an interface. An interface is just a bunch of functions, all of them are abstract, and anybody who says that I'm implementing interface, he has to extend all the functions, or he has to implement all the functions the way. So basically interface is more or less like a contract, that I'm abiding by this contract and I will provide the implementation of the all functions defined as part of this interface. Okay, So imagine that there is an interface called creature, and which has got two functions. One is move, other is eat. So that way, this interface does not have anything other than move or other than eat. So in that case, you just have to say animal implements creature, and that's all. And you get the output. Sorry, sorry, I was just, that was an invalid statement. So you have a creature which has got nothing in it other than bunch of definition of functions. And animal says that, hey, I implement creature, which means that animal has to provide the definition or implementation detail of each function, what exactly it is supposed to do. And okay, so here, like this, okay. Or you could also say public abstract class, and then you could say public abstract and put abstract everywhere. Okay, so you can think of interface as the whole abstract class, pure abstract class. Okay, also an interface cannot have any member variable, while abstract class can have member variable. Why? Because interface is a contract. Interface does not have any state. Interface does not have a constructor. Interface is just a contract. All right. So between the boundaries of two things, we generally create interfaces. Say, for example, I am implementing something provided by Hadoop. Say I'm implementing something provided by Hadoop. I would say that I'm implementing file system, and then I'll actually and the interface will be provided by Hadoop, and I will be saying my file system implements the file system interface provided by Hadoop, and so on. And I'll provide all the implementation details. Okay, and also note that we could have we could have this as abstract class and then skip one or two definitions. Okay, all right. Now quick questions, almost we are through. Okay, quick questions. What is wrong with this? Anybody? What is wrong with this class? We have interface creator, which has two functions, move and eat, and we have animal, which implements creature. Yes, it did not define eat. Good. Because it says that I'm implementing creature, but it did not provide the implementation for eat. Or this, you could correct it in two ways. Can somebody tell me what are the two ways you can fix this code? Okay, we could mark it abstract and we could implement the functions. Okay, now what is wrong with this? Quickly. Yes, yes. So basically, although it's completely valid to define like this schema, That's not a problem. The problem lies here. The definition of eat is different. Yes, yes, that's right. Now, okay. So that's pretty much about, you know, inheritance. I just would like to say a few more things which are not included in this. I think we should include somewhere. Okay. So, an animal who is a cat can implement multiple, a class can extend only one class, while it can implement multiple interfaces. Okay. So my class could be, say I have interface called I1, I2, I3, and I have got parent class or superclass 1. S- So my superclass name is SUP. So my subclass can say extends super, comma, implements I1, I2. It doesn't have to say comma here. I2 and I3. Okay. It cannot say if there is another class called SUP0, it cannot say something th- like this. Okay. It cannot say super comma super 0. Okay. This is invalid. Okay. So the multiple inheritance from multiple classes is not possible in case of Java, although C++ provides it. Even C# provides it, but in case of Java, it's not supported. And but it provides the you know, multiple inheritance by the way of interfaces. So now, yes, which means if it has one function f1 and it has f2, it has f3 and so on, then soup will have to implement f1, f2, f3 and so on. Okay. And even this class called soup will have same function, then also it's correct only, right? So when we are implementing the class, these functions, there will be no confusion as to which one are we implementing. Okay. Whether the, so f1 and f2, if they are identical in nature, there is no problem. Otherwise you can have overloading of functions. Okay. So basically making it kind of a class only, single interface with single extents and multiple implements makes it simple when we are when we have multiple classes with same functions. If you have multiple classes with same functions in a language like C++, it's a great amount of confusion that which one are we extending. Okay. That is that is the thing which has been resolved by having only single extents. So what if both I1 and I2 has F1? That's not a problem. But you will have to only implement it once. Alright? That is probably the biggest difference between C++ and Java is. Okay? In terms of language semantics. Now let's talk about data structures. Java provides very rich amount of data structures to you in the form of various things. First one is bit set. Bit set is nothing but a big array of big array of Boolean variables. Okay, it's like a big number, or you can think of a big array of Boolean numbers. It's just that it also provides you various kinds of bitwise operators such as AND or XOR, which were there in our basics, okay, where right shift, left shift, and all of that. So bit set has all those features. Okay, so those people who are not really very comfortable with the basic Boolean algebra, they can utilize bit set when they are dealing with lot of flags. So we can say set third bit to be true, set fourth bit to be false, and so on. Okay, because setting a particular bit using the basic Boolean algebra is actually pretty difficult. If you want to set fourth bit of a number as true, okay, it's actually a difficult thing. You'll have to do a lot of, you know, uh, Boolean, mean shifting, right shift, left shift, and then -1, -2. That's actually complex. Exactly for the same reason the bit set was created. Okay, bitset is very low overhead. In case of array is a high overhead compared to bitset. Okay, now there is another data structure provided called vector. Vector is nothing but a array which keeps on extending by itself as and when you are adding values to it. Okay, you should have a look at these examples which I am doing here. Here, first, in case of bit set, I created a bit set of 16 size. Then I divided each bit by 2 and set it, each number by 2 and set some values here. And then after that, I printed it. After that, I did A and B. And then I did OR, XOR, and so on. Similarly, and then in case of vector, if you go through this example, it shows you there's a vector. By default, we created a vector of 3 size, and every time it has to extend, it will create 2 more values again and again. So initial capacity is 3, current capacity is 3, and then it keeps on. We added 3 variables, so that is supported. The moment we added one more variable, it will add it, it will change the capacity by 2 and so on. Okay, so this is automatic extending array list, automatic extending array, but vector is hardly used. If you have to use, then use array list. We'll talk about array list also. Vector is a little older class, array list is a new one. Now the other data structure which is quite common, yes, this will be online, it's just that I have not put it yet. The other data structure which is quite common is stack. Okay, stack is, is like a big array in which you cannot insert the element at arbitrary point. You only insert the element at the last index. Okay, so and it keeps on, and when you take out the element, you always take out the lastmost element from this array. So this array is sort of like closed inside stack. I mean, this stack class makes sure that you do not write to arbitrary positions in this array. Okay, so you keep on adding and you keep on popping out. So stack is quite useful when you are dealing with lot of things. For example, when we talk about recursion, factorial 1, factorial 2, and so on, if you imagine, it's exactly like a stack. Okay, you keep on placing things in a stack. Most recent one is taken out first, and so on. Okay, using a stack, you can actually do a lot of implementation. Think about think about our example when I was saying that do a take a directory, take a folder, and using that file class, iterate over the whole structure and print all the classes. So you can actually utilize stack over there. Okay. So stack is quite a useful and a quite powerful data structure. Although it sounds like very simple thing, but it's actually very useful and powerful. All right. So stack is a simple class. It gives you one function called push, other function called pop, and then there is another function called get top. Top will tell you the element which is there and the last most element. The another data structure which is more popular is hash table. Hash table is a key value pair. So whenever you have to do a sort of lot of things, if you have been part of our Hadoop class, the word count example can be done quickly using hash table, but it's quite memory intensive. Okay, so hash table is a very fast lookup. It's like a dictionary for a key. You can insert an element, and then when you get a key get a get that try to get that value key, you get the value immediately, and it's pretty fast. So hash table is a very fast lookup mechanism. The only downside of a hash table is it's it is very memory intensive. Okay, so it's like a big phone book, or it's a data structure with which you can build things like phone book or a dictionary or a lot of things using hash table. Okay, then similar to hash table, there is a data structure called properties, which is designed specifically for managing the larger programs. So properties is basically an extension of a hash table which has key value pairs. Okay, and it has got one more angle to it. You can create a properties based on a parent property, and you can keep on chaining it, and whenever a user looks into this property object, if it is not found in the current object, the parent will be looked up. So that is the quality of the properties data structure. So whenever you are creating sort of a big program in which you read the configuration file locally, then you change it according to the user's behavior, and keep on doing it. So in those kind of cases, you will like to use properties kind of object. Okay. Now these all the things anyway were part of collections which I was talking about. The collections are is basically a library of data structures. And it also contains a library of algorithms. And these are all part of a package called java.utils.collection. Okay. And okay, so actually we can discuss collections and generics on Monday. Okay. So will that be okay if we have the next session? Maybe this will be a maybe 1 hour session on Monday. Okay. So it'll be like there are only how many slides for 12 more slides. So we can discuss it on Monday. In the meantime, go through all the program, try to run each of them, and try to understand what do each of them do. Okay. I've not prepared much of an exercise for this class. Okay. And okay. See you then, Chandra. Bye bye. All right. So Abhishek, let's keep it on 8:30 itself. All right. And yeah, because there are other people who have been promised the same time who are not part of the session. All right, so thank you very much, and we'll see you on Monday. Bye bye. Bye, Srivasant. Bye, Abhishek. Yes, yes, we'll upload everything. So one more thing, are you able to see it on your My Courses? You must be able to see My Courses, right? It will be available there. Bye bye now. I'm hanging up now.